So no matter where you are on your KQL journey, KQL functions are going to help you. If you're new and you know a couple KQL commands, it's going to help you. If you learn early on, you can benefit from a proper structure of, leveraging these functions. If you are, pretty good at KQL, it's definitely going to help you. Trust me, you're going to want to see this. And if you are pretty expert when it comes to building all these awesome KQL queries or workbooks, it still is something that's going to benefit for you as well. And let me show you why. Okay. So what is a function, right? A function is a set of instructions bundled together to achieve a specific outcome. Functions are a good way of having repeating blocks of code in a program. So if you have, code that you're kind of repeatedly using in your scripts, or you're doing something that could, you can kind of have sort of a script you call upon, this is something that you might want to leverage. Okay. And an analogy I would reference, or I kind of relate it to, is a blender, right? You have fruits that you put, or whatever items or inputs you have into the blender. And once you put into the blender, its job is to blend and give you a certain result or a certain output. The output is going to be that smoothie, right? And regardless of whatever kitchen product it is, there are many kitchen appliances that has a specific purpose, okay? And, within the kitchen, you may have, a mixer or a toaster or a coffee maker, but each one, you are giving it an input and out comes something that you desire, right? The same thing is with functions. And let me show you why. Let's say you have a KQL query script block. It's a block of code that's going to query your data, okay? And here is the function, and here's how you call the function. Let me show you again. Here is the function, and here's how you call the function. Do you notice anything different? It's a lot less code. You just call the function and you pass some arguments, and now the function runs it. Simple as that. It's so much nicer to kind of just run that code like this, right? And how does that work? Well, you're going to pass an argument, okay? You're going to pass something that is expecting, and you can pass multiple, strings or arguments, and it's expecting the type to be a string, right? So it's expecting that I'm going to see the Pokemon type. Is it going to be a string? So it'd be grass or fire or water Pokemon. I don't know Pokemon, but then it's going to take that value and inject it into the script where it's expecting that value to be. So in this case, we want to search the type 1 column or the type 2 column, and we want to search for grass. Okay, very simple. So what type of functions are there? Well, there are going to already be pre-built functions that are already kind of built in the code. So I recommend learning about this so you don't actually have to build your own. There are so many types of functions. An example is a function to do a calculation. We may already have it. You don't have to do it, okay? But if you need some other calculation, then maybe you might need to build your own custom function. And you can do this within the local script, or you can do it globally, okay? So for local, here's an example. This is a local function within the script. It's within and defined within the script. So it's in the constructs of the script. And imagine sort of this block is sort of a room, and everything you kind of build in here stays within the script. Does that mean that other scripts can benefit from this type of, code block? No, because it's local within the script and you built it within the script. It's a user-defined function within the script, and you can't really access it outside that script. So you have to shift it out. So in this example where, you're going to call upon that local script that you built. So you can build a number of local functions, and then, You built it out. You may have already started building functions and you didn't even know about it, right? You may have did a let statement and it had some kind of table, and then you reference a table. So you technically already kind of built a function, but you probably didn't pass any parameters or anything like that to make it more advanced, more smarter, okay? So by you spending time into building that blender, then you have a device that's going to automatically do things for you, and you just put in your input and you get output. You get the expected output, okay? So remember, if you want other script blocks to benefit from that function, you've got to shift it out into a stored function. And I'll call it a global function. That way, other scripts can benefit from it, okay? Other scripts can query and use that same function. So if you have a function that you built out that you feel like you could benefit from in other scripts, then make a function so that you can use it in those other scripts. It also works in workbooks and anything else that you have within that sort of table, okay? So let's talk about the sort of two different buckets functions kind of fall into. Either they're scalar functions or they're tabular functions. Most of the time you have been, if you've been doing KQL, you've been messing with tabular functions. And I'll explain the differences of each one, okay? What we just referenced just a while ago was a tabular function, okay? Well, first we're going to talk about scalar. That just means single output. If you think scalar, it just means single output. In the realm of KQL, it's going to be something that is not a table output, right? It's like not a table or a table, okay? And you're going to need to know this concept because you might run into issues where you build a function, you try to use it in your script, and then it doesn't work, and then you'll get an error that says this is not a scalar value or something like that. So if you are feeding a blender other blenders, that's not a proper input. You got to feed it proper inputs, okay? So just keep that in mind. When you build your functions, just know what scalar is: a single output. And what does that mean? All right, so let's build a scalar function. First, we have to name it. So whatever you put after the let, you name it. And then you identify arguments. You don't have to identify an argument, but then the function just becomes very, very one facet. It just becomes very simple, but you may just want a function that doesn't require an argument, that you just want to, build a really, complicated query, and you just want to put into, just a word that you want to call, right? A function. But if you pass an argument, you can perform, that argument becomes something you can use within the script, okay? So that number to add could be an integer, string, Boolean array. So that argument could be any type, right? And in this example, it's just going to be a long, right, number. So let's take the number 5. We put it into, and we add it to the script. So that number to add basically becomes a 5 plus 5 equals 10. If you think about, back in algebra, if there's an x, that x becomes something else, right? So it's a placeholder, right? Number to add is sort of like x, where it becomes a 5 plus 5 equals 10. You can actually put x if you want in number to add instead of just putting number to add, okay? So just know it's a single output. You put a 5 in, you get 10 out, okay? And it's like I said, it's not a table output, so we're going to generate a table. Range is a command that, or a mod or a function that you can use to basically generate a table. It will generate that x, x column, indicated by the character x right there. So range x from 1 to 10, meaning from about basically generate 10 rows, and we're going to step by 1. So we're going to increment by 1. So really this just builds a list of 10 rows, right? And it just goes to 7. This picture goes to 7, but just assume it's going to 10, okay? Now, let's extend it. Let's use the function we built out. So we want to extend, just means add a column, So we're adding, if you look at it, 2 columns. We're adding a +_5 column. That's the name. We're adding a +_10 column. That's another name. In the +5, we add 5 because we're calling the function add 5. And you see that number 5 in the parentheses, we're passing that and we're adding 5 to 5. So really, that's just 10 across the whole columns down. It's basically calculating every time for every single row, okay? And the +10 is adding 10 to the add 5, right? So 10 plus 5 equals 15, right? And it's, so right here, it's very static. It's not, it doesn't, you know, you can't really feed values into it. So really, let's take it a step further. Let's do a +_x. So we're adding another column, right? We're doing a pipe. We're going to add another column. And now we're using that, you know, the values in the x, we're passing it over. So x plus 5, and it becomes the value in that third, you know, generated column, that third dynamic column, which is +_x. You see 1 plus 6 for that row. I'm sorry, 1 plus 5 equals 6. 2 plus 5 equals 7. So you can now see that any value you pass here could be used. So if you think that you perform some form of parsing or calculation for just a single value, not a table, then this might be something that you could benefit from, okay? A tabular function is going to be a table output, not a single value. So when you call upon that function and you pass, you know, whatever arguments it requires, if it does require one, sometimes it doesn't, you get a table back. You don't have to make a table and then use it and then calculate it with those functions. You actually get a table back, okay? So how do we build that out? We're going to first name it. We're going to pass those arguments, the type, a Pokemon type, right? And now we're going to use that type. So here's the table we're going to query, right? So we're going to query the Pokemon table. This is going to be a table that you have available in your, you know, in your scope. And now those types are going to match to those type items, you know, variables in the script, right? We're replacing those type with whatever arguments you pass. So find Pokemon by grass type. And now we're going to basically pass grass, and we're looking for if type 1 column contains grass or type 2 column contains grass. And if it does, the expected result is only a table with these matching conditions. Okay? So, yeah. If you're building if you're going to use this multiple times, then maybe you will want to build a function that you just pass a string because you know you want to filter by grass or fire so that you can use it in another, you know, query. Okay. You don't have to build this whole string anymore. You can just call upon that function whenever you need that table and you pass those arguments. Does that make sense? It's demo time. Let's jump into a demo and show you what I'm talking about. Okay. So you can go to aka.ms/KQL Data Explorer, okay? And when you go to aka.ms KQL Data Explorer, it'll take you to a sample repository where you can kind of query data. You're going to need an Azure login to kind of log in, but once you log in, you don't need to, fill out any forms or anything. It's already a public environment that you can kind of query and, test some things out with KQL. And another way to do it is if you go to my website, TeachJing.com, okay? And once you go to TeachJing.com, there's a log analytics KQL playground as well as an ADX KQL playground. ADX is using KQL to query Azure Data Explorer stack. So you may want to put data in Azure Data Explorer and you can query that data set here, or you can go to the log analytics KQL playground, which is it's going to be very close to your Sentinel environment with the same type of log. So it'll also be a good area to test as well. So we're going to actually go into the Azure Data Explorer and show you that aspect. Okay. All right. So let's build a function. Let's build a function with something in here in this stack. Let me show you exactly what I did. So I went over here. Here are all the tables you can reference, right? And we're just going to look at security alerts. And hopefully you have some data there, but you want to set your time range to, I'm going to set it to like the last 24 hours where we can filter it so that we can filter that data set so it's not too much. If we don't do this, right, then it's going to be a lot of data. See, it's going to be, 16. Well, no, it's going to be more data, right? So you want to filter it. So we'll just do the last 24 hours and we'll work with that data set. And the 16 records. And as you can see, there's a lot of columns, right? A lot of columns. Okay. And what do we want to do? Let's build a function. Okay. So first, you have to identify a purpose of that function. Right now, I'm just trying to find, so you don't have to follow me. I'm just trying to see if I could find something. Okay. We have 2 alerts. Okay. I've summarized count. So I'm summarizing count by alert name. If you're curious, what I'm doing is I'm just trying to get an idea of what the type of logs there are. Let's say we want to build a function and we want to summarize. So this can be a summarize function. Okay. So let's rebuild it. I'm going to do let summarize alerts. And again, guys, we're just building something just to kind of teach you what a function is. Okay. Summarize alerts. Okay. We're gonna pass in some arguments. So we're gonna say search string it's gonna be a string, and then we're gonna build our function. We're gonna search the security security alert table. Okay. And we're going to where alert name has search string. Okay. So I'm, pause it if you need to catch up, but that is the string that I'm going to build. Okay. And if you run it, you're going to get something, you're going to get an error. And I did this for a reason. It says no tabular expression statement found. If you were to cut this function out and you were to just run it, it's going to be, it's not the same, but it requires you to have something that, it requires to have a table, right? So if I was to query the security alert table, nothing really happens, right? What I did was, though, I defined the function and I didn't query it. I have the summarize alert function that I made, but I'm not querying it. So let's query it. Summarize alert, and we're expecting the search string to be process. So now we're summarizing alerts by process. See that? I only see any alerts with the word process in it. See, summarize alerts by process, but it's not summarizing. So now we want to then summarize those alerts. Okay. Yeah, there's probably only one computer ID, but what we're doing is we're gonna first want to filter by that search string and then summarize count by the source computer ID. And when you run something like this, you're basically summarizing it, and hopefully you get a list of computers that only have that matching string. Okay. So that hopefully that gives you an idea of kind of, you built a function and then you do something like this. Okay. Now, just for the sake of the demo, let's do a scalar function. So let's call this a tabular function. Okay. Let's do a scalar function. Okay. Let add add 10. Okay, equals. We identify the argument, so we're gonna say, no, we'll call it x, and we'll say it's gonna be a long number, and then we're gonna do some curly braces, and then we're going to then take the x plus 10. Okay, if I run it, nothing happens, right? I didn't use the function. I have to use this function somehow by calling this, right, and doing something with it. Now, if I was to run add 10, see that? It expects an argument. Let me give it an argument. Now, if I give it an argument of 20, we want to add 20 to 10. You see the error says top level expression must return tabular results. The only result you can have here is the tabular result. Okay, so a scalar function is not going to give you a tabular result. Okay, here's what you can do though. You can do a print that, and now it's a tabular result. Print takes that scalar value and then just makes it so that you can print out something, and then you can add a something like that where you can name the column. But print just really prints out any values that you can use. So just know that any type of results that's going to be displayed in the box below that window, it needs to be a table, and a scalar function is not a table output. Okay, so now we are going to summarize alerts. We're going to take that, we're going to uncomment this. Okay, and if you don't know, those slashes are just comments. Comments just means the code won't run. Those particular lines are ignored. Okay, that's just basically what a comment means. We ignore those lines, and it allows you to kind of comment your script so that other people can understand what you did. So summarize alerts. Now we want to add a column. And how do you add a column? Right, do you remember that command? It's extend. Okay, and remember guys, when you're working this, you want to use your IntelliSense. So if you type extend, don't just type the whole word in and just copy it down. Press tab, open parentheses, or if you have this, you can actually click on extend, and then I thought you can click on it and it gives you more stuff. Where is that button? It's right here, the arrow right here at the end. See? So it tells you kind of how to actually use the particular operator. Okay, so we're gonna extend, and we're gonna make a new column. Okay, it's just for demo purposes, but we're gonna extend count plus 10 equals, we add 10 because that's the scalar function we built out, and we want to add that count column. Okay, so what is that count column? What was it? I think it was, let's look at it real quick. It was a count underscore. See? And if you want to rename it, let's rename it just for the demo. Is project rename, and we want to name just total equals count underscore. Okay, so we're just renaming it. See? So now we have a total, and then now we're going to extend. Okay, so first we're going to rename that column count, and then we're going to extend it. So add 10, we reference the column name so they can calculate. Let me ask you a question. When we do the add 10, how many times is that scalar function calculated? It's calculated for every row you have. So you have 10 entries, then we're going to calculate for each of those entries. Okay? Does that make sense? And we can even add another column. So you can do a comma. You don't actually have to do, you can do two ways. You can do extend another column here with the pipe, or you can just comma here and add more columns. So we'll just do, add 10 how about plus 50 equals add 10, and we're providing number 50. See? So we're adding now, we're adding more columns to this sort of result. So this one is calling this tabular function, which is a table result. We're calling these add 10, which is really that scalar function we called upon, right? So this is a combination of tabular and scalar functions all within the same query script. So let's make a stored function, all right? So you're going to need a workspace where you can save functions. If you, this is a read-only workspace if you're using my demo environments, so you won't be able to save functions, okay? Provided number, okay, plus 50. Okay, provided number plus 50. We save as function. We say add 50. We are going to put this demo. We're going to put this as long provided number. Save it. Okay. And if you put a default value, just a reminder, that means that it'll be the default value and you don't have to provide any arguments. The script will still run. If I run this, it doesn't work, right? Open up a new tab and call that one you just made. Oh, of course, it's a scalar function, so it's not going to have a table output. This view again requires a table output. This requires a table output. There's not a table output. See, it's just adding 50. Okay, but now I have that function available to me that if I do range and I do x, which is going to be that column name, so it could be like total, right? And then we do from 1 to 1000. Step 1, we just generated a table of 1000 rows, okay, with no columns. Like it really is just an indexed list. We're going to extend it, okay, and we're going to add another column. Let's add a plus 100 to the like a column. Extend means add. And we're going to call that add 50. And we're going to pass the total. Actually, we're going to pass 100. We'll pass a static number so you can see the difference. Okay. Now we're going to add another column. You can extend like this, like add another pipe, or you could just do a comma here. And we're going to plus total equals add 50 to my total. Okay. So we're basically calling the function twice, this one and this one that we made. We're calling that function that we built over here. And then this one is adding 100, just a static value. And the total is right here, which really is right here. Sorry. But that's the total. So we're just adding to that total number. Does that make sense, guys? So I now have a function that I can use that only provides one value, okay? So if you ever need to calculate anything and you just do it repeatedly, maybe it might be something you could use, parsing strings or whatever, something that you could use, right? That you already built out and is stored globally that other scripts can leverage. So anybody could do this. So if I open up another page, any script could leverage that function, okay? But remember, scalar functions are only single output, so let's build a tabular function. And this is something you probably already do already, is for a stored function, we don't do lets, we're just gonna build out our query, and then when you call that stored function, you pass parameters, it'll just inject the variables the arguments into the script block. So let's build our table, just a fake table. So let's do range. Well, let's just use the other one that we had. All right. So we have a range total from 1 to 1000, step 1, extend plus. So we have a pretty good column, right? And let's just add another one so you kind of know how this works. Static text equals blah. See, you're just adding more columns. All right, let's do another one. plus parameter equals, actually add 50 provided number. It's not going to work, but we're going to save the function anyways, because it will work, because it doesn't have the value yet. But if you're passing it through this function app, it'll get that value in. We'll call this random function, okay? And we'll put this as demo, and we'll need to store it. So we'll pass along provided number. All right, I think it looks good. So provided number is going to be the what it's expecting. So we gotta pass something in. If we don't, it's not gonna run. Let's open up another tab, random function, and we're gonna pass a number, 10. And there we go. See, 10 plus parameter right there. So 90, this 90 gets populated and this gets processed over here. Okay. Does that make sense, guys? We had a stored function, a tabular function. Inside it, it's using a stored scalar function, right? So this is just to give you an idea of how functions work. But in your case, you're probably gonna parse whatever table. Like, for example, let's just, you're gonna parse whatever table. And let's just do something for syslog real quick. If you don't have syslog, do it with something else. Doesn't really matter. We're just going to count by a random column. So just pick a random column. And then summarized computers. Just name whatever. Doesn't matter. And I thought I saved it. Let me just copy this to make sure. Summarized computers. Maybe in these parentheses. There we go. So now I never really need to call this special query. And this could be like a 100-line query, right? Or whatever, however long your queries are. And then you just kind of save it, because maybe you might use it repeatedly. So you just kind of save it as a function, then you call upon it, and then you can kind of join, join syslog, or maybe back to it on computer. I don't know, something, you can join tables together, just boom, boom, instead of just a longer script. Does that make sense, guys? Hopefully this explains functions. Go around and play, build your own functions, and make your life easier. Make yourself more efficient. Remember, you having a blender makes life easier, but you could definitely just, cut up some fruits and cut up some and make it into a smoothie by smashing, I guess, and eventually you'll have a smoothie. It's just going to take longer. Same concept. You can definitely just write this long query script. It's just going to take longer. And if you're repeatedly using the same blocks of code, store it in a function and use it. It's going to make you more efficient, and other team members can benefit from it, right? All right. So was this difficult? Hopefully it wasn't too difficult. Hopefully I explained it pretty well, and you have another tool in your tool belt, your KQL tool belt, to do anything within within the realm of KQL. And you could do functions within Data Explorer, Log Analytics, so you can store these functions and use them, right? Functions is going to be very important because in future episodes we're going to talk about parsing and building our own parsers, custom log parsers, and knowing how to build function is one of the key components to building these parsers. Okay, so thank you for watching, everyone. Have a good day and stay safe.